Now we're going to look at trinomial factoring when the a value, the coefficient of the x squared term, is not equal to 1. As an example, let's look at 6x squared plus 23x plus 7. We cannot do the method shown in the last section about trinomial factoring when a is equal to 1, because in that case we would need numbers that would multiply to 7 and would add to 23. There are no such possibilities. This 6, however, changes it. So here's what we're going to do. There are two ways to do, well, one way to do it and then a simplified version. I'm going to show you the longer version first, then I'm going to show you the simplified version, and that'll be the way to think about it. We know that we are supposed to make it into two binomials, but it's harder to do now since we have this. Somewhat harder. So what we're going to do is we're going to take this number and we're going to multiply it to the 7. So what we're going to do is a times 7. A, or a times c. This is the a, and this is the c. A times c is equal to 42. So what we do is we're removing the 6, and we're changing the 7 to a 42. So in other words, instead of ax squared plus 23x plus 42, or ax squared plus bx plus c, what we actually just did is taking the a out, plus 23x plus a times c. So we're moving the a over here and multiplying it. So we still have, though this is supposed to be b, we have a and we have c and we have b, just the a is over here now multiplying. So we have x squared plus 23x plus 42. So this is gone, the b is still 23, but the a times c makes 42. This is one where we can do like this. So we can do 42, multiply to that, and add to the 23. So the multiples of 42 are 42 and 1, 21 and 2. Oops, right there I can see 21 and 2 would add up to the 23. So if 21 plus 2 adds to 23, and 21 times 2 is 42, what we have is a 21 here and a 2 here. But what we have to do is, I'm going to have x. So we have x times x to make x squared. 21 times 2 is 42, and x times 2 is 2x, and 21 times x is 21x. That adds up to 23x. But now what we do is we have to put the 6 back in here. So we do 6x plus 21, 6x plus 2. Now we look at this and see, can we reduce this? In other words, can I divide both of these by the same number and simplify it? It's not really reducing, but it is taking out a common factor. So if I take a 3 out of both of these, I can get a 2x plus 7, and I can't take anything else out of these. Here, I can take a 2 out of these, and I have 3x plus 1. 2x times 3x is the, whoops, I'm sorry, I moved down the page and didn't move it up for you. Okay, so now I'll move it up. So what we did here is I put the 6's in here to make 6x plus 21 and 6x plus 2. Divide both of these by a 3 because it's a common factor to both the 6 and the 21. Divided these by a 2 because it's a common factor of 6 and 2. I get 2x plus 7 and 3x plus 1. Now, 2x times 3x, that's the 6x squared. 7 times 1 is the 7 at the end. 2x plus 1 is 2x. 7 times 3x is 21x. 21x plus 2x is indeed 23x, like we have here. So if you multiply this one out, we get the original. So that means this is the answer. Now, notice two things. One of them is you take out 3 and 3 from here. So really this is 3, 6x plus 21. And this one is a 2, 6, oops. I am sorry. Take the 3 out and it's 2x plus 7. Take the 2 out and it's 3x plus 1. This 3 and this 2 multiply to make a 6. It is the only time in math where you can throw away a common factor after you've taken it out. The reason for that is there's only one 6 here. But I put 2 6's in. I only need 1. So by taking out the common factors, I take out enough to count up or to multiply to make one of those 6's. So what I'm left with is, well, that's an inadvertent line, so that's 2x plus 7 and 3x plus 1. Multiply it out, you get the 6x squared plus 23x plus 7. This is a case where it's very useful to multiply it out to be sure, because there are more steps and it's a little more complicated than the other one. It's not as obvious if it works. 2x times 3x is 6x squared plus 2x plus 21x plus 7. 6x squared, 2x and 21 is 23x. And that was the original problem that we started with. So here is your answer for that. The other thing I wanted to mention, besides the throwing away of one of the 6's by taking it out as a common factor, a mixture one, is that back here, when I put the 6's in, I could have just put 6x's at the beginning. That's what we do in the simplified version of it. Okay? Now that you see how that works, might as well just do it a little simpler. Once you realize that 21 times 2 is the 42, and that 21 plus 2 is the 3, is the, whoops, I didn't write the 23 in here, that's 23x when I set it up. And that 21 plus 2 is 23, and that means that when I bring this over here and make 42, okay, so I can do x squared plus 23x plus 42, but when I set my parentheses up, immediately I should put that 6 in with both x's. Whatever this was, I put it in immediately. I don't worry about putting it afterwards, I just do it immediately. Over here I see it's the 21 plus 2, so I do plus 21 and plus 2. Now I can take out the 3's. So what I really have is a 3x plus 7 and a 3x plus 1. Right? Nope, that's a 2x here. 2x plus 7 and a 3x plus 1. And this 3 times 2 makes 6, but you just get rid of it. It's the only time, remember, that you get rid of it. Well, now let's put those here. 2x plus 7, 3x plus 1. Check it, but we already did that on the other page. So we know that 2x plus 7 and 3x plus 1 multiplies back to get 6x squared plus 23x plus 7. So I recommend that you take the a out, multiply it to the c, a times c, put it in place of that, and set up the parentheses automatically with the 6x and 6x. And then you figure out over here what these are and put them in, take out the common factors. So I guess this would be like step 1. This would be like step 2. This would be step 3. This would be step 4, is to take those out. Now, let's look at a different example. Here's one now that has a couple of negatives in it. The other one were both pluses. It will still be the same idea. I'm going to take the 7 out, x squared minus 26x. So I'm going to do a times c. That makes for a negative 56. Okay. Now I'm going to take that negative 56 and I'm going to see what numbers multiply to that, and we'll add up now to a negative 26. Okay, so here I was thinking what other things. Some of them are easy here. I'm going to have a 1 and a 56. Problem with that is that one of them has to be a negative. I'm going to have a 1 and 56. That one would be negative. Now I can look at 2 and 28. And one of these would be a negative. Now this looks better because I add that. I'm getting to, is it, no, let's see. Oh, wait a minute, it's not. That would add up to 52. So it needs to be a 28. Multiply. 28 times 2 would make a 56. But this would make a positive 26, and that's a negative 26. So instead, let's do it with these two. So I see here I get a negative 26, and it looks like that would be our combo, because 2 times negative 28 makes negative 56. 2 plus a negative 28, or a negative 28 plus 2, or 2 minus 28, whichever way you'd want to say it, you get a negative 26. So I'm going to take that 7 though now, and I'm going to put it with immediately into the air, and I now know my two numbers to do it with. Now I'm going to take out a common factor. This one there is no common factor that comes out. But this one there is. 7 and 7. So I get 7x plus 2, x minus 4. This should be the answer. I'm going to box it, but I'm going to check it anyway. By the way, this 7 now, it's gone. You know, a 7 times this would have given me x minus 4, but I don't need it. I put in 2 7s, but I only need 1. Let's check it. Seven x times x, there's our 7x squared. This makes negative 28x. This makes plus 2x. And here you can see we're going to get a negative 26x. And here we're going to get the negative 8. I guess I put it there and then now I'll simplify it. 7x squared minus 26 minus 8. 7x squared minus 26 minus 8. So that means that this is the correct answer. So remember these steps. Take the a out and multiply it to the c. Set up the parentheses with the 7 in with both of the x's here. Go over here and figure out what numbers multiply to negative 56 and add to negative 26. Put them in here with it. Oh, put them in here first, and then take out a common factor. This time it's not both, it's only one of them. You take out the common factor, and voila, you have your answer. Okay, now, here is an example, actually 2 examples. I'm going to do one, so do this one, pause the video, and I'll start in 5 seconds, but you just don't need to start until you've done with it and trying it your first, and then you can unpause it. Okay, go ahead and do that now. Alright, here are the steps we're going to do for this one. I'm going to take the 12 and multiply it to the 6. X squared plus 17x plus 72. Okay, so now that I have that, I'm going to take that 12x and put it in both sets of parentheses. Over here I'll figure out what multiplies to 72 and what adds to 17. So I'm going to start, of course, with the simple 1 and 72. That doesn't do me any good to get to 17. 2 and 36, so half of 72. 3 and 24, that still gets me, if I subtract, well, it's all adding, so that doesn't help me. 4 and 18, okay, that one doesn't seem to help me. 6 and 12, that makes 72, still doesn't help me with a 17. 8 times 9, there we are, that multiplies to 72, okay, and it adds up to a 17. If I were to add them, multiply them to make 72 and add them and it makes 17. So it looks here that those are the numbers I'll need to put in here. 12x plus 8, 12x plus 9, neither are negative, so it's all pluses. Now I'll look for the common factors. It looks like I can divide both of these by 4. That makes for 3x plus 2. Both of these I can divide by a common 3. There, 3 times 4 makes up the extra 12 that I put in, so 112 is getting out of here. And this gives me a 4x plus 3. Okay, I'm going to box it, but actually maybe I should wait until I actually multiply it. 3x times 4x, that one does indeed give me 12x squared. 3x times 3 is plus 9x. Here I have a plus an 8x, and here I have plus a 6. 9 and 8 does indeed make 17, so 12x squared plus 17x plus 6. That means that 4x plus 3 times 3x plus 2, this thing times that thing is indeed the correct factoring of this one. Okay, here's another problem to practice. Please pause the video and I'll start up talking in 5 seconds video time. You can unpause it and pick it up as soon as you're done. Alright, I'm back, and now we're going to look at doing the same thing. I'm going to take the 8 out temporarily. 8 times 25 is 200. I'm going to set up my parentheses here with the 8x back in here. I'm going to come over here and see what multiplies to 200 and adds to a negative 30. Okay? So what that means now is I need two numbers that if it's going to be, something's going to be a negative in it, but I have a positive number. If this is positive, the only way I can have negatives involved is if both numbers are negative. So that means I can do -1 and -200. Well, that's not going to help me much here, it looks like. -2 and -100. -4 and -50. That's not getting me like 30 either. -5 and -40. See what I'm doing? I'm doing 1, 2, 3, doesn't work. 4, 5, just happens to be with -2. -6 doesn't, -7 doesn't. -8 times -25 would give me 200, but it doesn't make a 30. -10 and -20, aha! If I multiply these, I get a positive 200, and if I add them, I get -30. So a -10 and a -20. 8x minus 20, 8x minus 10, doesn't matter which one we put them in. Now, let's take out common factors. From both of these, I can take out a 4. I would get a 2x minus a 5. Both of these, it looks like I can only take out a 2. So I'm going to get a 4x minus a 5. And now if I multiply it, 2x times 4x is the 8x squared. Here I have a minus 10x for doing this one times this one. Now the inside one. -5 times 4x is -20x. Multiply these and I get a positive 25. So far, I put these together. 8x squared minus 30x plus 25. That was the original, and that means this is indeed the correct factorization of that trinomial. So remember now, those are the steps that you want to focus on. Is 1, make this a times c. 2, set it up with the 8x's in there. 3, do all of this to figure out what are the two numbers to go in with them. And then 4, take out the common factor. And I should say the fifth thing to do is to check it. You really should. You don't need to, but you do need to if you might get it wrong. I've seen numerous times people come up on tests with answers where they clearly did not check it, or they would have multiplied it and seen that it wasn't anywhere close to the original. All right, so now you have seen it with positives, with negatives, when both the negatives, number of different possibilities here. Just remember those steps and practice as many of these as you can. This is one of the most difficult ones most usually for people because they forget the steps and they don't check afterwards in order to go back and realize, oops, I had a negative wrong or a number mixed up. All right, so please check them every time you do them to be safe.